Okay, so this is Module 1 of the IPCJ standard, Rev H. The objective of this module is that you will be able to locate appropriate clauses and apply the requirements and criteria of the J standard 001, Rev H. For Module 1, in this video, we will be going over Section 1 as general. Sections 3 and 4 and 8 and 12 are covered in the other two videos, and Section 2 is not really applicable. It's just a list of documents that are in the same vein or related to the IPC that aren't really relevant to this class. So the scope, so right up here where it says 1.1, right up here where it says 1.1, that means that it is in your PDF or in your book. It is section 1, clause 1, so 1.1 scope. This standard describes materials, methods, and acceptance criteria for producing soldered electrical and electronic assemblies. The intent is for a user or a manufacturer or a technician to rely on process control methodology. We'll get into what that is later. It is not intended to exclude any procedure that is capable of producing acceptable products. So say if you have a method that isn't listed in the IPCJ standard, but it still produces an acceptable product, and when it's inspected, when it's tested, or anything like that, if it still produces good work, that doesn't mean that it's excluded just because it's not mentioned in this book. Okay. This is table 1. This is what the tables look like. You'll find these throughout the J standard. This is just, what board types and design and fabrication acceptability specification. So if you're an engineer and you are designing a rigid printed board for fabrication, you would go rigid printed board, fabrication specification, and then IPC 6012 and IPC A600. That's how to read a table here. This does describe materials, process, and acceptance requirements. There is reference information in other IPC documentation. Use of an amendment or newer revision is not automatically required. I believe I mentioned in class that there is actually a Rev J, but we are still teaching to Rev H. That is what we have the books for, and it's still, it's recent enough. There was actually no Rev I, it just went from H to J. We did touch on this in class. So class 1, class 2, class 3 is determined by end item use. So what the actual product, the end product, is used for, that determines what class is going to be. The user is responsible for assigning the class. The user is the customer, the person who is purchasing or ordering those parts. So, the user is going to determine, hey, we need this, test board as class 2. We need this assembly to be a class 3 because it's going into an airplane. The classes reflect differences in manufacturability, complexity, performance requirements, and verification frequency. Verification frequency means how many times it's inspected or tested. When it's class 1, it tends to be, one piece out of, 100 parts or 1,000 parts. When it's class 3, it tends to be, 1 out of maybe 5, or 1 for 1. Those any requirements like that in the class is typically going to be stated in the procurement documentation. So when you're purchasing something from your supplier and you need it to class 3, you need to specify that in your document, in your contract. We need this to class 3. We went over this. Class 1, general electronic products. Class 2, dedicated service products. And class 3, high performance or harsh environment. Remember that class 3 is what we do our lab work in class 2. We do our work to class 3 specifications. You will see in this book, we're now in clause 1.4. Everything in this book that's in measurements is expressed in System International, also known as metric. The Imperial English is what we use in America, is in the brackets. So in the brackets next to that number. So 0.75 millimeters, which is a very small number, is actually the equivalent of 0.03 inches. 3/100ths of an inch. Very small number. Verification of dimensions. So when we're, especially when we're doing surface mount, we're talking about a very, very thin amount of solder. Actual measurements should be for referee purposes only. Referee purposes means if you can't tell if it's a pass or not, then you measure it. Usually it's done by eye. If I'm looking at something and I know you're not supposed to have more than 25% tilt, and I'm looking like, oh, I can't tell if that's 25% tilt, I may take a measuring tool to that, a very small, fine scale or, ruler to determine if it's really, within 25%. But I'm not going to sit there with a ruler and inspect every part on every board. We would be sitting there forever inspecting everything. Round all observed calculated values to the nearest unit. So if the measured value is 0.602, you can round it down to 0.6. So 0.6, the specification shall not exceed 0.7. If it's rounding to 0.6, in the example it gives here on the left, this would actually be acceptable. And actually, it would be acceptable even as 0.7 because it shall not exceed 0.7. We touched on this in class as well. The NAPD. N is no requirement, A is acceptable, P is process indicator, D is defect. Now here's where something else that you really need to know about the book and the J standard, any IPC standard really. You will see the words shall and shall not. Shall and shall not are used whenever there is a requirement. Okay, so like in this example, there shall be no strand separation. That means it is required that the product that you're working on has no strand separation. We'll get into what strand separation is a little bit later in this module, and also we'll talk about it more in module 2. Okay. So bracket steps. So to figure out if the black bracket applies. Apply the clause to the observed condition or operation. Do they match? So like in this one, in the last one, like is there strand separation? No, there's not strand separation. So they matched. So there shall not be strand separation. You look at it, there's no separation. They match. So would it be acceptable unless no requirement established? Do they match? No, they do not. If you're looking at it, oh, there is strand separation. Then you select the class and condition from the bracket. So for this one, if rework of encapsulant is necessary and there are no documented procedures available for review, what is the condition for class 2? And here is the rule for that, the associated clause. Procedures that describe the removal and replacement of encapsulant material shall be documented and available for review. But it's not. But then so this does not match, so we look in the brackets. What does the bracket say? N1, N2, D3. So it is only a defect for class 3. It is not required for class 1 and 2. What is the condition for class 2 product? That's going to be a no requirement. That's a similar question right there that we can just skip over. Now here's where it is a little different. There's also the word should. Should reflects recommendations. It's not a requirement, it's just strongly recommended. Now you have to be careful. Sometimes you'll see the word should written on tests or written in clauses. You have to consider what should does not necessarily mean yes or no. It just means a very strong suggestion. Drawings and illustrations are to assist interpretation. If the drawing doesn't match the text, so say if there may be a little bit of confusion, like maybe the picture doesn't necessarily reflect what the words are saying, the words take precedence. The words are what matters. The drawings are just there really just as a helper. But that doesn't necessarily mean that they're always going to be right and always going to be clear. Okay. So this is strand separation right here, also called bird caging. So there shall be no strand separation greater than 1 strand diameter are the requirements of the statement met for class 1. So class 1 says it's acceptable. So no matter what, yes, it's acceptable, even if there is strand separation greater than 1 strand diameter, which there is right here. That's a pretty big gap right there, but it's acceptable for class 1. Now right here, there shall be no strand separation greater than 1 strand diameter. Is this requirements met for class 3? Yes, because there is a slight bit of strand separation here, right here between these two little hairs of wire, but it's less than 1 strand separation. It's only slightly apart. It's not a full strand worth. So that's also acceptable. Hardware defects, we're on section 1.5.1. Hardware defects affect the fit, form, or function of the item in its end use. They shall be identified, documented, and dispositioned. This is obviously a burn, right? Looks like somebody may have gotten a little too close with a heat gun or a hot knife. Something burnt the insulation here. Process indicator is caused by variation in material, equipment, operation, workmanship, or process. It does not affect the fit, form, or function. So that's where it's different from a defect. So that this is what I was saying earlier in class, that a process indicator is saying that it's an indication that there's a problem somewhere in the process. And it is saying, okay, we'll take it this time, but if this keeps getting worse, it's going to turn into a defect. So process indicators should at least be monitored. You don't necessarily need to disposition it, but they definitely should be monitored. What constitutes a hardware defect? If there's a defect that applies to the product that isn't necessarily called out in this standard, the user, who is the customer, the person ordering the parts, the user needs to define additional defect categories that are applicable to this product. And the manufacturer, who is the supplier, who is the one building the product, needs to identify defects and process indicators that are unique to the assembly process. And then they can document, like, hey, just so you know, this tends to happen, or this may happen when we're putting these things together. Material and process nonconformance. So this picture right here is where gold plating has corrosive residues that are not visually apparent. That's probably from flux. We'll talk about flux later. This is not always something you can see. It can impact performance, and it is something that will degrade over time. I actually have an example of this in our classroom. Affected hardware shall be dispositioned, and disposition, so basically is written up, and we'll talk a little bit more about disposition later. Disposition shall address impact on functional capability, reliability, and longevity. So is it going to work? Is it going to continue to work? And can we count on it continuing to work? For specialized technologies, it may be necessary to develop unique process or acceptance criteria as long as they are not in violation of what's called out in the IPC. That's magnetic windings. We don't care about those. High frequency applications and high voltage applications, they may require something different. There are different rules that apply to high frequencies and high voltages that are beyond the scope of this class. However, there shall be no broken strands for wires at 6,000 volts or greater. So K means 1,000. So 6K volts or greater, 6,000 volts or greater. There shall be no broken strands in your wire. Opportunities determination. Total number of connection points used to determine defect percentage. One connection point is one possible defect. This has 26 opportunities. If you divide 100 by 26, you'll get approximately 4, because 100 divided by 25 is 4. So each one of these opportunities is approximately 4% error. So it's like basically a 4% chance. For statistical process control, I don't need to go into this too much, but the use of statistical process control is encouraged but not mandatory. When it is used, it shall include these elements. There should be training, evidence that the statistical process that you're implementing, either with data collection or training, on-the-job training, something like that. Make sure that that is being documented and that it is being followed correctly. It needs to be implemented when sample-based inspection is used. So what I mentioned earlier about instead of one, you're looking at every one, you may go down to looking at one in every 10 or one in every 20. If you get a shipment of 20 boards in, you may only look at one or two to see like, okay, these are good. I don't see any defects. This is going to indicate that these are fine. If a defect exceeds the limit, inspect the lot 100%. So say if you have a group of 100 boards and your inspection rate is 5%, and you look and you're only allowed to fail one of those 5. And you're looking and you see 2 of them with defects. You have failed your threshold limit. Now you have to inspect all 100 of those boards. Okay, inspect the lot 100%. And then a system is in place to initiate corrective action. So, okay, we have 2 out of these 5, that are defective. So now we have to inspect 100, all 100%. And then the corrective action is, okay, how are we going to fix this? And they're going to most likely inspect those 100. Every lot of 100 that comes in, they're going to inspect the full thing until enough time has passed where they're not finding the defects. That would be a corrective action. There should be a documented audit plan, and objective evidence is maintained. So objective evidence is test results, test printouts, any kind of data collection like that. That is what's considered objective evidence. It's evidence that cannot be skewed by opinion. Order of precedence. You may see something about this on the test. The contract shall take precedence over the standard. Reference to standards and engineering documentation. Okay, so we have contract, user approved engineering documentation, which is some engineering documentation that the customer has looked at and said, yes, this is what we want. The J standard, and then applicable documents. However, I will say that engineering documentation does tend to be based on the J standard, and your contract is typically, if your buyer has done their job correctly, is going to call out the engineering documentation. So this should all be connected. Appendices to the standard, which is kind of like add-ons, the appendix, are not binding requirements unless separately and specifically required. There are definitions in this module that are used throughout the book, so we will go over those. You will hear me talk about area voids of solder. This right here is a cutaway of, it's like an x-ray, almost like cut version of this black area right here is actually a hole, a void in the solder. It's an air pocket. It's an internal void in the solder fillet, and it extends around the entire circumference of the through hole and or leader wire. This is what happens when you try to solder in from both sides. So this right here, the bottom of the board, that is the solder source side. This is the solder destination side. If someone tries to solder on both, you're going to have an air pocket in here. And this is bad because inside this air is a lot of contamination. You have a lot of moisture, you have oils, just little tiny bits of dust and dirt. And that's just has nowhere to go, and it's just going to sit there and corrode away at your lead wire. You'll hear me talk about diameter. There is a conductor diameter, which is the collection of strands, and also, oh, sorry, I lost my mouse again. So that's that's the strands. There we go. Sorry. The collection of strands, that's your conductor, and that whole wire, including the insulation, is the wire diameter. And each one of these little hairs is a strand diameter. Defects. So this is disposition. We mentioned disposition earlier. Disposition means the determination of how defects should be treated. Dispositions include, but are not limited to, rework, use as is, scrap, and repair. There is a difference between rework and repair. Repair is when it's typically something that's done aftermarket, like if you're out in the field, something that's already been sold and installed by the customer, by the user, and it breaks and you need to just have it fixed real quick. Get it basically back to functionality. Repairing is restoring functionality to the unit. Rework is restoring it to a like new condition, and that's typically what's done in manufacturing. If you're working in manufacturing and you have something break before it gets to the customer, then it's basically reworked until it is like new. And then that is considered rework, not repair. Scrap is when it costs too much to fix it. You might as well just throw it in the garbage. You're not going to spend $10 in labor hours to fix a $5 part. They'll just toss it. And use as is when, you know what, yeah, there's a scratch in the surface, but engineering has looked at it and they've determined that it's fine. That would be a use as is. But they better document it, just in case. These are two words that you will hear me say so often you'll start to doubt they're real. Electrical clearance. You'll also hear me saying minimum electrical clearance. That is the spacing between two parts that are not common, so they're not on the same circuit. Uninsulated conductors, that minimum spacing is minimum electrical clearance. There is no actual number for this. It is dependent on the size of the components, the size of a board, and I believe maybe even like what the functionality is. I've had a student ask me, so what's the number? Is it 0.1 inches? Is it 2 millimeters? What is it? It's like there is no actual number. It depends on the size of the components and the size of the board. That is in the design standard, which is IPC 2221 or whatever. In the absence of a known design standard, use Appendix B of this book. Engineering documentation, that is your drawings, your specifications, any kind of technical illustrations, or other documents like work instruction that are prepared and released by the design activity in any form of media. So whether it's printed out on paper, whether it's available as a software, as long as it is in some sort of form of media, like actual media, that establishes the design and the design requirements. Okay, we touched on FOD. Foreign object debris is defined as a generic term for a substance, debris, particulate matter, or article alien to the assembly or system. High voltage will vary by design and application. High voltage criteria in this document are only applicable when specifically required in the documentation. I want everybody to remember that. The high voltage criteria is only applicable when specifically required. You'll notice a high voltage board is in red. They are typically in different colors just to alert the technician that may be working on it. Hey, this is high voltage. You want to be careful. A manufacturer is the individual, organization, or company who is building the parts. They are responsible for the assembly process and to make sure that everything is compliant to this standard. Objective evidence, again, that is documentation in the form of hard copy, data, video, or other media that demonstrates the requirements and standards have been met. Process control is a system or method to continually steer an operation into reducing variation. So DMAIC, actually this is wrong, it should be DMAIC, should be improve then control. This picture is actually backwards and drives me nuts. Define, measure, analyze, improve, and control. It's something in your workplace you may have heard of lean manufacturing or Six Sigma. These are the rules of Six Sigma. Proficiency is the capability to perform tasks in accordance with the requirements and verification procedures detailed in this standard. So again, solder destination side is where the solder wants to end up, and solder source side is how you get the solder in there in the first place. When we're doing surface mount, it is the bottom of the board. If you solder from the top, I will know, and I will catch you. Solder void, this is something that can't be seen with the naked eye. This is done with X-ray. A void is not identifiable during visual solder inspection because it's covered by other solder and you can't really see. Supplier, again, that is the person who's actually building the part. Tempered leads, we'll talk about tempered leads a little bit. Component terminations or pins that have been heat treated or chemically treated that incorporate hard, brittle plating layers. Tempered leads are not to be cut, they're not to be bent. They need to be left alone because even though it's for strength, because that layer is actually kind of brittle, if you bend it or cut it, you can break the outer layer. User, again, that is the responsible party for the buying of this hardware that's being built by the supplier or manufacturer. We'll see this a little bit in the book, especially in Module 2, talking about wire overlap and wire overwrap. Overlap occurs when a wire crosses itself. See how this one where he's like giving himself a hug? That is overlap. Wire overwrap is when it occurs when the wire is wrapped more than 360 degrees around a pin or a turret. This is a turret connection. And remains in contact with the terminal post. This is what we want to see. We do want to see overwrap, not necessarily overlap because it does lose connection with the post. When required, this J standard shall be imposed on all applicable subcontracts. So if we have a whole bunch of other people buying parts that are going to be built into the next assembly, that all of these will apply to all of those components. This, J standard, everything that's written in J standard will apply to all of those components until you get to the point where it's COTS, which is commercial off the shelf. If it's a washer or something you can go into Home Depot or Grainger and buy, these rules do not apply to that because they are publicly available. Personnel for proficiency is when the instructors, operators, inspectors shall be proficient. Objective evidence shall be maintained. So basically, when you do on-the-job training, you need to sign something saying, yes, I did this and this and this, and then your boss signs it. That is the personnel proficiency objective evidence. This is an X-ray specific machine. There's other trainings available, at an employer for that. We don't do that here. Acceptance requirements. All products shall meet the requirements for the product class specified. If sampling is part of the documented control plan, that's one thing, but otherwise it should be 100% inspection. Process verification inspection. shall include the surveillance of the operation. Visual inspection, so this is when you're looking at something to make sure it's okay. So sample base is common for large volumes. You see there's hundreds of these things. You don't want to go through every one necessarily. Inspection shall be either sample based or 100% visual inspection. So if it's something, it's like these would probably cost somebody, whatever these things even are, probably cost somebody, $20 or something, for 100 of them, whatever this is. It looks like maybe it's a Switch or something like that. Or you have this card right here that could have been thousands of dollars on its own. That's when it determines, okay, do we do a sample base or do we do a one-on-one? Lighting. Illumination of the work surface should be at least 1000 LUX, which is lumens, which is the measurement of light. That is the equivalent to 93 foot candles. And that is obviously Imperial English because that sounds like just the kind of thing a king would do. Measure how bright something is by how many candles you can light up in a square foot, or whatever that rule is. Supplemental lighting may be necessary, so that just means do you have an overhead lamp? If you're inspecting, do you have a flashlight? That's what supplemental lighting means, and it may be necessary, and that's fine. Light sources should be selected to prevent shadows. Next time we're in class, if you hold your hand up over the table, you'll notice that you don't have a very stark shadow. We have diffused lighting in that classroom. Magnification aids, eye loops or microscopes, they shall be in accordance with tables 1, 2, 3, and 4. Magnification power shall be based on the size of the land or wire. Land is what's the little metal bits on the board where you solder the components, which are the loose metal bits, onto the board. Any power within range may be used. For mixed wire or land sizes, the greater magnification may be used for the entire assembly. If a defect, now this is something I want you all to know because you may have to get into a fight with an inspector one day, like I used to, over rules like this. If a defect cannot be determined at the inspection power, the item is acceptable. If you're looking your acceptance power, which is I think in another couple slides, the table for that. If a defect cannot be determined at the inspection power, the item is acceptable. So if you're looking at it and you've got it up to the max, 4x or whatever, and you can't tell if something is a defect or not, it's not. Record-free magnification is used for defect determined but not completely identifiable. So if you see something like, look, I see something is there. Is that a piece of fluff? Is that dirt? Is that a shadow? What is that? That's when they use referee magnification and go up a notch. Like, okay, can they zoom in and see? The tolerance for magnification aids is plus or minus 15% of the selected power. Magnification aids should be maintained and calibrated, so like in our microscopes. Supplemental lighting may be necessary. Again, a flashlight for inspection is very common. So here's the table. This is table 1, 2. This is for land widths. Again, those are the little metal areas on your board that you will be soldering the components to. And then table 1, 3 is magnification for wires and wire connections. Right here where it says 14 to 22 and then less than 22 to 28 gauge. In wire, the larger the number, the smaller the wire. So 14 gauge wire is way thicker than a 28 gauge wire. There is an exception to this table, I believe. Yes. Well, no, this is continuation. I think there may be an acceptance difference with the very smaller wires, like 30 wires, but that might also be in termination. And also when you're reading these tables, the notes are your best friend. So make sure you always read the notes. Facilities, cleanliness in the work areas shall be maintained. Eating, drinking, smoking, vaping, chewing tobacco, any of that stuff, don't smoke a pipe. Or use of tobacco products shall be prohibited. Yeah, they don't mess around with that anymore. Environmental controls. The soldering facility should be enclosed, temperature and humidity controlled, and maintained at a positive pressure. So basically, they want you to be clean, warm, and dry. Temperature should be between 18°C and 30°C, and that is in Fahrenheit. In American Fahrenheit, is about 64 degrees and 86 degrees Fahrenheit. Humidity shall allow all processes and materials to function properly, and also the operator, the relative humidity should not exceed 70%. If anybody's from the East Coast or has lived here long enough to be dealing with some of these nasty monsoons that we get out here every summer, that is where your relative humidity goes up. And just so you know, in the middle of a windstorm, you shouldn't be soldering. This little thing right here looks like a little pop-up tent. That's exactly what it is. This is for field assembly on class 3. If you're working on the field on something and you don't want to get contaminated, say if you're in the middle of the desert, middle of the jungle, whatever, this will help protect you, what your soldering is, what you're working on with solder. Health and safety. The use of some materials referenced in the standard may be hazardous. They're typically talking about lead. And so it just says, hey, make sure you follow all the guidelines. I know California, I think, has something about it, but we don't. ESD, which is electrostatic discharge. There shall be a documented ESD control program, and that documentation shall be available for review to an auditor. Okay, so section 1 review real quick. We are going, actually, you know what? We are going to do this on, Tuesday. So let me see what we have left here. Don't peek. Don't peek. Don't peek. Here's section 2, is your applicable documents. This is that one list I was showing you, like, yeah, none of these things affect this class. These are things that exist out there: aerospace standard, military standards, SAE, international. But right now we are concentrating on the IPC. Okay. Section 3. I think actually my video for section 3 actually may miss a couple slides, so I'm going to go into there. I know where it starts. So section 3. Again, this is still module 1, but section 3. This is still in the module 1 PDF, and it's still module 1. It's just in section 3 in your book. Materials and processes shall produce acceptable products. I think that goes without saying. You want your processes and your procedures and how you're building something. You want it to build something that's going to work, right? I mean, that's kind of why that's why manufacturers are in the business of manufacturing. When major elements change, validation shall be performed. So what that was showing was, they changed a process. So a major validation basically needs to be re-inspected, like, can we do this? And then they evaluate, and yes, it can be. When specified, manufacturers shall have a PB-free control plan. A PB is the symbol for lead on the periodic charts. So when specified, manufacturers shall have a lead-free control plan. Lead-free does tend to create little whiskers here, depending on the air pressure. I know this happens, I think, on space programs. And they'll get what's called tin whiskers. Okay. Materials, there shall be a documented process to control materials that age, flux and solder and things that have an expiration date. there needs to be a process in place that controls that, so we're not using expired materials in production units. Limited shelf items and limited shelf life items shall be stored IAW, which is in accordance with. If you see IAW, that means in accordance with vendor guidance, so who you buy them from, and the manufacturer's documented procedures. So say if the vendor says, yeah, you should throw out this flux after 2 years, and the manufacturer says, actually, we have it where we're throwing out old stuff after 18 months. You want to go with the tighter manufacturer document. Materials shall be processed per the material specification or other documented procedure. When curing conditions vary, they shall be documented available for review. So say if you have your parts in an oven and they're curing, where they're held at a certain temperature for a certain amount of time to make sure that all the epoxies are set and all the glues are set and everything like that. And say if you know that the power glitched for like 3 minutes in that oven, you want to have that data available for review to make sure that everything you cured in there was done properly. Also, I think I just missed that last one. I can go back. If you are using a silicone material, yeah, it has to be mixed separately with separate tools. You can't mix silicone and non-silicone based items. If you've ever touched silicone, had any kind of silicone on your hands, you would understand why it doesn't typically always play well with others. It's very slippery. And it can contaminate your bowl or your measuring spoon, mixing spoon, or any other material that comes in contact with it. Solder alloys shall be in accordance with J Standard 006. Other alloys may be used if objective evidence is available for review. Typically, we'll use like a 6337. That's what we have in our class, I believe, 6337. So it's 63% tin and 37% lead. Solder alloys less than 0.1% lead, not listed in J Standard 006, may be used when such use is established between the manufacturer and the user. And lead-free processing shall be in accordance with a documented procedure that includes controls to minimize the risk of cross-contamination. For solder purity maintenance, solder baths shall be analyzed, replaced, or replenished in accordance with Table 31, and the frequency shall be adjusted based on historical data or monthly analyses. So if you have a solder bath, which is a way to do waveform, or maybe you're just dipping your parts in it to tin, and your solder gets kind of gross, and it has like all of these little metallic bits floating in it that aren't the bright metallic bits, and you need to clean it once a month. That would be the frequency. But say if it hasn't been cleaned in a month and you get there and there's way, way more gunk than there should be, you may look to say, well, maybe we should clean this every 2 weeks until we figure out what's causing this contamination. Flux shall be in accordance with J Standard 004. There shall be an activity levels of L0 and L1 of rosin, RO, resin, RE, or organic, OR. Flux ORL1, so that is organic level 1 flux, shall not be used for no cleaning. So we have rosin, low activity, and then 0%. So that's what ROLO means. Other fluxes may be used, but data shall be available. Type H or M, which is high or medium, fluxes shall not be used for tinning of stranded wires. External flux may be used. We actually do use use external flux in our class. It comes into the form of a little tub of paste, and I highly recommend you use flux whenever you're soldering. Adhesive materials should conform to a document or standard. The adhesive selected shall not be detrimental, so it can't be like super glue going onto something, because if it breaks, it could rip the board. The material shall be cured in the oven. And then additional criteria is in 10 and 11. Okay, so this is actually where the next video picks up, is right here, talking about chemical strippers. So this is about 43 minutes. I apologize for how long this one is. The other two videos to get through the rest of the slideshow, we're about halfway through right now. It's much faster. So each one I think is about 20-ish minutes long. So if you have any questions about this, let me know. And you can text me, or you can email me through the Canvas dashboard. There's an inbox. And also I will be sending out a group text to make sure everyone else has my number. And if you have a question, make sure that you can text me. And if you text the group chat, maybe you're asking a question that no one else has the bravery to ask. Okay. So there you go. That is Module 1, Section 1, and a little bit of Section 3 that looks like it got deleted out of the Section 3 video that is included in the lessons for this week. Okay, so I will see you in a bit.